Here we are talking about one of the most important concepts in geometry and shapes, and that's this idea that we could have two shapes be congruent. Now, congruent means that they're exactly the same shape and they're exactly the same size. And one of the ideas in geometry that we need to know is that if we have two triangles or two shapes that are congruent, then all their parts also have to be the same. Kind of like if we had two congruent trucks, we would assume then that the tires are the same and the steering wheel is the same and the car stereo is the same and the windows are the same size. When it comes to triangles, one of the things that we can conclude is that the parts are all the same. So for example, if I know that triangle ABC is congruent to triangle DEF, there are 6 things that I know. I know these 3 angles match up with these 3 angles, and I know that these 3 sides all match up with their corresponding parts. So for example, one thing I could write is that angle A is in the same place, is congruent to angle D. And there's a couple of other angle statements that we could make. Angle B is congruent to angle E, and angle C is in the same place as angle F. So that would be 3 statements. And then the other statements we need to make is about the sides. The side AB is in the exact same location as DE. And so we will say AB is congruent to DE. Now in this case, the order of the letters is important, because when we want to say corresponding parts are the same, that are congruent, we want to make sure that the points that correspond are in the right order. So if I go AB, then I want to line that up with DE, because if I were to take this triangle up here and slide it down on top, A would be in the same place as D, and B would be in the same place as E. Now, it doesn't matter whether the shape we're dealing with is a triangle or some form of a quadrilateral. If shapes are congruent, that means all the parts are the same and all the angles are the same. So for example, you can take a look at this side here, L, looks like it's in the same place as R. So this angle at L is going to be the same as that angle at R. And this angle M is going to be in the same place and is going to be the same number of degrees as angle S. And angle J, I'm going to go ahead and put 3 little marks through there. That's going to be the same as angle P. And I guess I'm down to 4 marks for K. This angle K, which is this big obtuse angle, is going to be the same as that angle at Q. So it doesn't really matter the shape, because we have this rule that says corresponding parts of congruent figures are congruent. And so when we're usually talking about triangles, we might change this statement into CPCTC, or corresponding parts of congruent triangles are congruent. But in reality, it applies to any figure. So if we're talking about a triangle, usually this letter will be a T. And if we're talking about any shape other than a triangle, then we might replace it with an F. But corresponding parts of congruent figures are congruent. So we can make the same conclusions about the sides. JM, one thing we could say is that JM must be congruent to, and if we get the letters correct, JM, PS. So that would be a congruent statement. And the answer to our question, can we make conclusions about corresponding parts? Yes, we can. Because if shapes are congruent, all their parts have to be congruent as well. Well, let's take a look at how we can use corresponding parts to identify other parts of congruent triangles. So let's take a look at example 1. We know that we are given that triangle ABC, which is this triangle here, is congruent to triangle DEF, which is over here. And what we have here is this rule of CPCTC, corresponding parts of congruent figures. Sometimes we're talking about triangles. That's where the T comes from. And the rule is that if two figures are congruent, then all their corresponding sides are congruent and the corresponding angles. So we can take a look at this shape and say, how can I make triangle ABC sit right on top of DEF and line up? Now, this angle here at C doesn't really look like it's the same as angle E. This one looks a little bit more acute. And angle B looks more like it lines up with angle E. And A is on the top and angle D is on the top. And so one thing that I know right away is that angle A must also be 73 degrees because that's how many degrees angle D is. Angle F is 42 degrees, and I think that angle C lines up more with angle F, which makes this angle over here 65 degrees. And another thing that you can look at is if you look at the order for A, B, C, since A is the first letter, it corresponds to D because the order of the letters is important. So A, wherever we see an A on this triangle, it's going to correspond to D on this triangle. That's why angle A and angle D are the same. And just the same way, angle B is the same as angle E, so 65 degrees and 65 degrees. Okay, we're going to hop back on the algebra train here for a second, and we are going to find some missing lengths and some missing degrees. So one thing to pay attention to is when you see some of these algebra expressions for either sides or angles, pay attention to the symbols. So this little degree symbol means that 5y plus 11 is referring to that angle right there. And 3x plus 8, just as inches, it's representing this length of this side. So over here, 6y plus 2 degrees, there's a degree symbol. That's representing that angle right there. And 5x inches is not an angle, it's a side. It's this side right here, DE. And I notice that I have AB over here, which is 3x plus 8. And I look up here, and I know that AB is in the same place as DE. So, and this question is asking me, how long is AB? That's what AB means without a bar over it. It means how long is the distance from A to B. And on this question over here, they're asking me to find the measure. That's what that M stands for, the measure of angle D, which is how many degrees is that angle. Notice they're not asking me what X is or what Y is, but we do have to figure that out. So let's find AB. I know that the length of AB is going to be the same as the length of DE on the triangles. And I'm going to go back over here to AB, and AB is 3x plus 8. And DE is 5x, and I am not going to walk you through this solving of this equation, but let's go ahead and solve it real fast. Okay, now that we're done with that, we need to find out how long AB is, and AB was this 3x plus 8. Well, let's plug a 4 back in and figure out how much that's worth. 3x plus 8 is 12 plus 8, which is 20. And so AB is 20, in this case, 20 inches long. And if I take the value of X and plug it into DE, 5 times 4 is also 20. So that sort of sings some harmony there in that both those sides are congruent. Let's go find the measure of angle D. I know that the measure of angle D must be the same as it's over here, the measure of angle A. So if I take a look at the drawing, we can figure out A is 5y plus 11 degrees. So I'm going to go ahead and put 5y plus 11 degrees. That's what A was, and D was 6y plus 2. And we're going to go ahead and take a second and solve this one. I'll speed it up for you. Now the problem didn't ask me what y was. The problem asked how many degrees is angle D. Angle D was 6y plus 2. That's 6. That's 6y plus 2. which is 54 plus 2, 56 degrees. So the measure of angle D is 56 degrees, and if I take a look at angle A, should have been 5 times y, that's 5 times 9 is 45, plus 11 is also 56 degrees. So there we go. The measure of angle D is 56 degrees.